there, it's Jillian, and today we're going to take a look at exponents and polynomials. So let's start off with exponents. First of all, you need to remember that in math, and you've heard me say this many times now, math is a language. So you need to know what the rules of the language are, and then you just follow them. So with respect to powers and exponents, let me first do a little bit of vocab here for us. So here is, let's say we have 5 to the power of 2. So this is called an exponent. This is called the base. And the whole thing is called a power. And we read this, the way we say it is 5 to the power of 2. There's another way of saying it when it's a 2. You can say 5 squared, because squares are two-dimension. When something's two-dimensional, we say it's square. When it's 3 dimensions, like this, we say cubed, because we know cubes have 3 dimensions, length, width, and depth. But anyway, this is an exponent. This is a base, and the whole thing is a power. And again, we read it as 5 to the power of 3. Now, what exactly does that mean? Well, that means this is code for 5 times itself 3 times. 5 times 5 times 5. And you know that 5 times 5 is 25, and 25 times 5 is 125. Now, if you can't do that in your head, in other words, without a calculator, just think about money. If you have 25 or quarters, 25-cent pieces, if you have 5 quarters, in your head quickly you can do that you have $1.25. That's all you're doing. You're counting in quarters or in 25s. So now let's take a look at some examples and just going through some things. Here we've got 4 times 4. And 4 times 4 is, another way you can write it is 4 to the power of 2, right? Now, if we were asked to evaluate this, we would also write 4 squared equals 16, but we're just asked to write it as a power. And we know a power is something to the power of something else. So here this is 1, 2, 3, 4, 5. This is 4 times itself 5 times. So I'm going to write it as I say it. 4 times itself 5 times. Okay, this is negative 2 times itself 3 times. This is negative 2 times itself 3 times also. So let's talk about the brackets here. Okay, sometimes brackets make a difference, sometimes they don't. And as we go through things, you will see when they do and when they don't. But for the most part, what you just need to know is this means all of negative 2, as opposed to something like this. Because that is, it ends up equaling negative 2, but what that really is this is negative 1, because when there's nothing in front of a bracket, it's negative 1 times 2, and then of course it ends up equaling negative 2. But this is first equal to this before we simplify. And the reason why I am taking such painstaking detail explanations to go through all this bracket stuff is because later on it's going to, if you know this like the way I'm explaining it, then later on when the questions are more complicated, you don't have to also think about, well, what does it mean with the brackets, because you'll know. If you're sitting there wondering, I don't even know what the hell she's talking about, why is she going on all about these brackets, just kind of go with the journey, just sit back, relax, listen to what I'm doing, and just follow along, and you'll have your light bulb moment later on. All right, now let's hear this says evaluate. So again, that means if it's not written as a power, which it is, we could have written it as a power, and then we're going to evaluate. So this is 3 times itself 4 times. So that's this times this times this times this. Now maybe you can't do 3 times 3 in your head is 9, 9 times 3 is 27, 27 times 3. Maybe you can't do that in your head. But because of BEDMAS, an order is not important when it comes to multiplying. In other words, you could multiply this times this, and then the answer times this, and then the answer times this. When it's all multiplying, you can group things. So you know that this times this is 9, and this times this is 9, and then 9 times 9 is 81. So you can do that. Group stuff together. It'll help you with multiplying, adding, subtracting, all that stuff. Here, we've got 4.1 times 4.1. So I'm going to let you do that on your calculator. However, you could also just do it like this. 4.1 times 4.1. 1 times 1 is 1. 1 times 4 is 4. Then here we've got 4 times 1. Put a 0 there. 4 times 1 is 4. 4 times 4 is 16. Add them up. And then we have 2 decimal places, so we have to go 1, 2, and we're at 16.81. So it's really important that you say 16.81. 16.81 is not how we say that. That's like writing, hey, yous guys, in an essay. You would never, ever, ever do that. Your teacher wouldn't like it. It's not proper English. And saying 16.81 is also not proper math. So we say 16.81. I can't have you guys walking around the halls of your school saying it incorrectly. You'll just look like goofballs. So anyway, that's how we say that. So that's 16.81. Here is where we're going to start to see the difference of what happens when we have a bracket and when we don't. So here we have -3 times itself twice. So this is -3 times -3, which of course is negative times negative is a positive, and 3 times 3 is 9. And I know you're used to just writing it like this, but I want to just write this there as I'm explaining it so that you can follow along and see that I haven't forgotten about my signs. Here, this is not the same as this. Because of BEDMAS, we know that we do exponents before we multiply. We do exponents before we multiply, right, in order. So negative in front of something is -1, and then we have 3 squared, so that's times 3 times 3. So this is this, and 3 squared, of course, is that. So now we have 3 times 3 is 9, times -1 is -9. So you see these brackets make a difference when you have a negative number in front. 1 to the power of anything, of course, is 1. 1 times 1 is 1. 1 times 1 times 1 times 1 times 1, you get the idea, is equal to 1. Now let's take a look at this, these two here. Here this says, we just went over something like this, so this is -1 times 1 to the power of 3. So 1 times 1 times 1. And then, of course, that's equal to negative, and all of that is 1. You might not need to have written all that out, but again, I'm just writing it out now as we explain, as we go over the explanation. Here, this is -1 times itself 3 times because of the bracket. So we've got -1 times -1 times -1. And we know a negative times a negative is a positive, and a positive times a negative is a negative. And here 1 times 1 times 1 is 1. So it ends up that these are the same. Please note that that doesn't always work. Don't go making up your own theorems without checking it out with a mathematician first. Okay? Anyhow, so that's that. So what I want to do here is I want to just talk about in general, because we're going to, in high school you start more and more talking about general things. So if you have -1, we know that +1 to any number, even, odd, it doesn't matter. 1 to the power of 4 is equal to 1. 1 to the power of 5 is equal to 1. 1 times itself any number of times is 1. But -1 to an even power, well, let's do some examples. So we have -1 to an even number. Here's -1 to another even number. So this is -1, times -1. And -1 times -1 is, of course, positive 1. 1 times 1 is 1, and negative times negative is positive. Let's see here. We've got negative 1 times negative 1 times negative 1 times negative 1. 1 times 1 times 1 times 1 is 1. And now let's do the sign. Negative times negative is positive. Positive times negative is negative. And negative times negative is positive. So you're going to see that over and again, you've got here these powers to the negative 1 to the power of an even number, and it's always going to come out to being positive 1. What happens when we have negative 1 to an odd number? Well, let's see. Negative 1 to the power of 3. You go ahead and do that while I just make this a little neater. Negative 1 to the power of 3 is negative 1 times negative 1 times negative 1. And what's that equal? Let's see here. Well, negative times negative is positive, and positive times negative is negative, and 1 times 1 times 1 is 1. And let's see here about negative 1 to the power of 1, right? 1 is an odd number. Well, negative 1 is just negative 1. So you're going to find if you do negative 1 to the power of 5, 7, 9, 11, and all the other odd numbers, that negative 1 to an odd number is always going to equal negative 1. So I want to explain something to you. This is not for you to memorize, okay? If you are the type of person who has been memorizing math up until now, you're going to need to get a little bit out of your comfort zone and start learning how to understand math so that you don't have to memorize everything. Like, I don't know that anyone has a brain big enough to memorize all of high school math. You need to be able to learn and understand what's going on. And just so you know, if you force yourself to explain it out loud to somebody, you're going to find that you're going to just get so much more understanding, and you're going to cut down the number of hours you need to study for tests and all sorts of stuff. Your homework's going to be done faster if you start explaining it out loud. Now, just don't get me wrong here. I know that most people don't go home and then look in the bathroom mirror and start talking to themselves and explaining math. Like, I don't. But find a study buddy. In class, find someone. Like, talk about it. Say, I'm going to explain this to you, and then you explain this to me. I'll talk about that technique more later on, but I just wanted to show this to you for now. Have a good one.